you can see the database management system, mainly the relational database management system. Let us start from this definition of this data. What is database and what is database management system and what is this RDBMS? So we'll study all this concept one by one. If you come to the definition of this data, data is some type of information that is collected for a specific purpose. For example, the raw facts, the figures or statistics that have no meaning on their own. So these can be numbers, it can be text, it can be images or other type of information collected for specific purposes. For example, you can take the name of the students or name of the employee, then address of the students or employee, then phone number, then the product price for any product and catalog. All the things, this can be the example of data. What is the purpose? Data is the fundamental building block used to create information so when it is processed or organized. That is the main thing why we need this data. And what is this database? If you see this database, it is organized collection of data. Whatever the data previously we discussed, when we go for the organized collections, we call it the database. So what is this purpose? They can be stored and accessed electronically. It provides a structured way of storing data, making it easily retrievable, manipulate, and update. So these are things. For example, suppose I go for a customer database that stores names, address, and transaction histories. So this can be a database. What is the purpose? A database organizes data into tables like rows, columns, and fields to make data management more efficient and meaningful. That is the purpose of this thing database here. Then coming to the database management system, DBMS. So this is a purely software, and we call it as a software system that interact with the user, applications, and the databases itself to capture data, to store data, manage and retrieve data from the database. They ensures that data is organized and accessible efficiently and securely. So, for example, if you take the MySQL, the PostgreSQL, the Oracle, Microsoft SQL Server, these are all the example of database management system. And what is the purpose? The purpose of this database management system, it acts as an interface between the database and its users or applications. Then what it does, it allows for data manipulation, querying, and ensuring data integrity, security, and consistency. What is the summary you see till now? Data is the raw fact, and database is the structured collection of the data, and database management system is the software that manages and manipulates the database. Right now, so before we go for this database management system, let us see, did anything exist before this database management system? Yes, it was the file management system that we were able to maintain in the Excel sheet, the CSV file, and this type of things. It was the file management system we are maintaining just in the form of a file. The definition of this file management system: a system that manages data stores in individual file or a computer or storage device. And it provides basic file handling operations like creating, opening, reading, writing, and deleting the files. So it is purely a file management system. Then what is the structure? The data is stored in flat files, usually in the format like text or binary, with no relations between the data in different files. So what is the data in your file that is only useful? You cannot relate with others, right? Then there is some problem like the data redundancy. So in this file management system, there will be high redundancy since the same data may be repeated in multiple files and each applications may have its own files reading the data duplications. Clear? So file management system, the first drawback is the data redundancy or duplication. Then is the data integrity. So limited data integrity checks upon prone to inconsistencies as there is no centralized control over this data in the file management system. But this is overcome in the database management system. And data access, the data retrieval is often manual or semi-manual in case of file management system. So requiring user to know the structures and the location of each file, searching large amount of data, it can be very slow. Then what is the security? Security related, what is the problem we are facing in the file management system? Basic security features typically file systems offer limited permissions like read, write, but lack more granular controls. Concurrency, so difficult to manage concurrent access. That means at the same time, multiple users accessing the same thing, it is difficult. You cannot do it here with the file management system. Then flexibility, it is not a very flexible. Any changes in the file structures or applications requires modifying the entire file and related codes. Fine. And what is the example? So storing employee details in a set of individual text files, the XLS file or the CSV file, these are the example of all the things. Then we go for this, the alternate to overcome all the things, that is the database management system or the DBMS. So this DBMS, it is a software system that manages database and provides user and applications with an efficient and systematic way of storing, retrieving, and the manipulation of the data. So the structures, data is stored in a structured way because the DBMS data is stored in a structured. That means it is the row, column, tables, fields like this, with defined relationships between the data entities and supports normalization and also data modeling. These are the things which happens with the database management system. This is a comparison we are going between the file management system and the database management system. Then we are talking about the data redundancy. Redundancy here means duplications. So here minimal redundancy due to data normalization techniques which organize the data to avoid duplications and maintain consistency. So this is the advantage of database. The data integrity, strong integrity constraints such as suppose you want to use primary key, I want to use foreign key, etc. That is possible here in our database management system, which was not possible in the file management system. Then data access, it provides powerful query languages like SQL or the structured query languages to easily retrieve data. So you can select any data from anything, you can join anything, you can do it here. Then you can update, you can delete data. The faster data retrieval due to the indexing and optimized query executions. What is the security part here in the DBMS? The advanced security features like the fine-grained control over who can access or modify specific data with role and permission ensure that unauthorized access of data is prevented here. That's why it is secured. I cannot say it is 100% secure, but it is secured in comparison to the file management system. Then concurrency, the manager's concurrent access, it manages concurrent access effectively, ensuring that multiple users can work with the data simultaneously without conflicts. For example, say suppose you want to see your result in the BPT website, then what you do? At the same time, some thousands of people they want to check it. So, but in case of no, this Excel sheet, it fails. You cannot see. Thousands of people cannot see the same Excel sheet data. But what happens here if you put the data in a database management system in a server, then with concurrent users, thousands of students can also check the data at the same time, same instance of time. Then flexibility, it is highly flexible, and it allows for modification of the database schema without affecting the existing data. That is the most important things. That means if you want to affect the schema, if the existing data is affected, then it is not flexible. But DBMS also supports complex querying and data relationship. Third one, what are the example? We have a number of relational databases like MySQL, Oracle. So these are all coming under this relational database management system. If you see the key differences in the file management system and the database management system, first of all, while you talk about the data structures, flat files, there is no relationships. So you create one file in Excel sheet, we cannot establish a relationship between them. The database management system, structured tables with relationship, it is possible. And data redundancy in file management system, it is high, but DBMS, it is minimum. Data integrity is low and prone to inconsistencies. The data integrity is high with strong integrity constraints. And data access, manual or limited automations, here easy and efficient with query languages in the DBMS case. Concurrency, it is poor in case of file management system, but in case database management system, it is effective. Then security, basic permission only you can give, but here high-end security is also possible. Then flexibility, low flexible in case of file management system. In case of database management, high flexible, and it can be easily updated and extended. Then what is the efficiency? It is slower for large scale data retrieval in case of file management system, but in database management system, it is optimized for large data sets and also queries. That's why it is efficient. Then the example, we take the CSV file, the Excel file in case of file management system, but in database management system, MySQL, Oracle, PostgreSQL, these are the things what we discussed there. The summary what we find, file management system is simpler, and suitable for basic data storage but lacks advanced features like relationship, security, and efficiency. Whereas in DBMS, it offers a powerful, structured, and scalable approach to managing data, especially when dealing with complex earth. So these are the things. Then, in addition to that, there are several database management system. We can categorize into many types. First one is the hierarchical database management system. Hierarchy you can understand. So just like it is a tree structure. Okay. Here the structure organized data just like a tree structure with the parent-child relationships. So top is the parent and bottoms are the children. Like that, these relationships we can maintain in the tree structure. And each child node has only one parent, but a parent can have many or multiple children. Then the data model, it is hierarchical or the tree structure. Example is the IBM Information Management System or IMS, right? So this is the first type that is called the hierarchical. Then is the network database management system. In the network management system or the network database management system, the structured data is represented in a graph where entities are nodes and relationships are edges. So one node means just a circle. It is connected with one line that we call it as the relationships are edges. And each record can have multiple parents and child records. Okay. And supporting more complex relationships than the hierarchical database management system. So when you go for more complex, then network database management system it is better than the in your hierarchical. And the data model it is just network graph structures with many to many relationships. Example are the integrated data store IDS and IDMS, that is the integrated data management system. These are the example use cases when data has many to many relationships, such as the network models or the telecommunications. So you understand, in case of telecommunications, we go for this network database management system. Then the relational database management system, the RDBMS. The structure is stores data in tables, also called relations. That is the first thing. Where rows represent records and the columns represent attributes. Relationship between tables are maintained through keys. We can call it the primary key, foreign key, or any type of key. Data models, that is the relational tables with rows and columns. Example is MySQL, PostgreSQL, Oracle, Microsoft SQL, and servers. Then use cases most commonly used for the business applications, web applications, and also transactional system, the banking system. Then is the object-oriented database management system. Here the use cases we use for the CAD system or AI applications, and example is DB 40, then object DB. These are the data models are object oriented, store data in object and with the different attribute methods and attributes like. So these are the examples. So these we are using similar to how objects are stored in OOP like C++, right? Then we are calling the document oriented database management system, that is the NoSQL. See, there are things where you not only find binary numbers or number system to store in fields, but certain data can be stored as we store in the JSON, JavaScript object notation, the BSON. Each document can contain nested key value pairs. So you want one is the key, for example, name colon. In case of name, you can write in double quotation Gunamani. So registration number, you can write colon 501. Suppose my registration is 50, like that, or in the type of arrays and other documents. So data models, so they are the document based, just like store documents with flexible schemas. Example is MongoDB and CouchDB. Use cases they are suitable for big data applications, real time analysis. For this type of people, it is suitable their document. Then the next one is the key value or DBMS or NoSQL. Here you take the example, and the example is the Redis, Amazon, and DynamoDB and React. So these are the things. So it is best for caching, session management, and real-time recommendations engines. This is the things we use it there. And the structures uses a very simple key value pair. Okay, so it is similar to that what we used in our previous one. Uh, you get it now, just like the MongoDB, right? Then, if you see the example here, we have different type of database and what are the different type of structures and what is the example of the database. What you studied, the same thing is summarized here. So these are the things we use it. Then the question comes, why use the RDBMS or the relational database management system? Relational database management system or the RDBMS are widely used for a variety of reasons. First one, data organizations and structures. Okay, so it is in maintained in the tabular form, in the form of a table, row and columns, and the data is stored in the fields only. Okay, so for example, you can take the customers or the products, all things. We the relationships RDMMS allows the establishment of relationship between the tables using keys. Say for two tables, for example, one is the student personal details and student attendance. For both the table, the key we can take is the student registration number or the university registration number. It works as a primary key, right? Similarly, second one, the SQL. We have a powerful query language, that is the structured query languages. So this is the standard languages used to interact with the RDBMS. So it allows user to query, insert, update, delete, or manipulate data with ease. In the data retrieval also it becomes very easy here. Clear? Then the data integrity. Data integrity means integrity means here means some constants. For example, we cannot make any ID duplicate. Name can be duplicate because one name is Ramesh. There can be same number of Ramesh in the class, but their ID, student ID, or the university registration or employee ID, it cannot be duplicated. Okay, so these constants we can put it here. Then the normalization, the process, the data normalization helps minimize the redundancy. One thing, while in the file management system there is a lot of redundancy. In the RDMS, it minimizes or reduces the mm, inconsistency or the normalization. Okay, redundancy. Then data security. Here is the access control. RDBMS systems provides mechanism for controlling user cases and privileges. So this is the data security, data encryption and backup also. Here also we use the same thing, data security. Then we go for the scalability and the performance. RDBMS uses indexes to improve the speed. Okay. Then concurrency, RDBMS handles multiple users at the same time. And another thing, the acid property, that is the atomicity, consistency, isolations, and durability. You know these things. We call it the atomicity, acid property. A for atomicity, C for consistency, I for isolation, and D for durability. So these are the properties. What is the atomicity? Suppose there are two accounts, account A and account B. Okay, account A has $1,000 and account B has $1,500. Okay, and there is a transaction. There is a transaction from account A $500 to account B. So it should be 1,000 minus 500. It will be 500 and 1,500 plus 500. It should be 2,000. Okay. So before transaction and after transaction, if you add both the balance, then it should be same. But what happens? Suppose one transaction is going on. In the meantime, there is a power failure or the server crashed. Then what happened? From account A, $500 is withdrawn, but it is not deposited in B's account. Then what happens? Then it leads to inconsistency of the data. Where that money $500 is not a small amount. So these are the things, property, atomicity. That means then what is the remedy? So it has to roll back. Either the entire transaction is to be carried out, or it has to roll back, or none of the transaction is to be carried out. Then the data consistency. Before transaction, after transactions, it should be same. It should not difference. Okay. That is the thing. Then consistency across the relationship should be same. Then it supports for large scale applications. That is the reason why we go for this RDBMS or relational database management system. Then what is the common example of RDBMS? Say MySQL is one of the things. Here we use the WordPress, Joomla, LAMP, Linux, Apache, MySQL, and PHP. Here we are using the MySQL or MySQL, whatever you say. The open source relationships are commonly used for web development. While you go for web development, use PHP and MySQL, then you go for the MySQL, right? Then you go for the PostgreSQL. So this is open source object relational database that supports both relational and also non-relational querying. Here the key features known for compliances with SQL standards, support ACID property, and advanced features like full text search for JSON storage. Like so, these are things the PostgreSQL. The next one is the Oracle database. So this is the commercial RDBMS known for its high performance, scalability, and reliability. Use cases widely used for large enterprises, financial systems, data warehouse, and also transactional systems. Key features support complex queries, advanced security features, and high availability across distributed systems. Then is the Microsoft SQL Server. This is the relational database management system that is developed by the Microsoft. Okay. So mainly we use for the .NET framework, Azure, like that we use it. And this is strong integration with the Microsoft tools, supports for large scale enterprise applications, data warehousing, and also data analyst. Like then you go for the SQLite. It's a lighter version of the lightweight services. This is the serverless or DBMS, typically used for the embedded systems and also small applications. Use cases ideal for mobile application. You are developing mobile apps. So if you go for some database connectivity, if you integrate with all the RDBMS, it will be very big. And so we go for the lightweight, and usually these are the SQLite. Clear? Then use cases ideal for mobile application, desktop applications, and also small scale web applications. Key features: zero configuration, self constant, and very lightweight. So these are the things. Then coming to the SQL, this is the structured query language. It is the one of the very powerful programming language. We can put all our queries and get the result there also. Then the key features and what are the examples, you can see it here. The use cases also you can see it here. Then there is something like the semi SQL here. No, so there, and another is the yeah, another the you can say NoSQL. NoSQL means when some data, semi SQL means you can take it in the form of JSON, JavaScript object notation, or like the XML. Okay, extensible markup languages. There you for the semi SQL, but when you go for the NoSQL, when the data can be in the form of a images, or it can be audio. So because anything carries some information, we call it as data. You know it. So it is not necessary that it will be in the tabular form, and not necessary that it will be in the field. It will be maintained like binary number or number system, but it can be any type of data other than that. Okay, the real time applications. So these are the things, the key features you can see it here. Then type of NoSQL databases we are having: Redis, DynamoDB, and React. The key value and document like the MongoDB, CoachDB, and the column family stores like the Apache, Cassandra, and also HBase, and graphic database like Neo4j, and also Amazon Neptune. These are the things you can see it here. The different use cases are here. You can see the key differences. And finally, we got some idea about what is the database management system, and relational database management system. I hope you enjoyed these things. If you like these things, you please share with others, and also don't forget to subscribe this channel. And the next video will go in details about the relational database management system. Thank you for watching this video. Have a good day.